Hi, I'm Anders Hejlsberg, and I'm a Microsoft Technical Fellow. My first sort of real introduction to coding was probably in high school. The high school I attended was one of the first high schools in Denmark to offer the students access to a computer. And this is before PCs or anything like that. It was actually technically what we'd call a mini computer. And I think it was an HP 2100. It had 32K of ferrite core memory. You could literally open it up and see the little ferrite cores. And paper tape reader, a teletype, you know, and then we got like a real CRT terminal. And I learned to program that thing in Algol. And it was kind of like, for the first 2 weeks, the teachers would teach us, and then we would teach the teachers, because you just had to discover it all for yourself by trial and error, right? So when I started at the Technical University, I met another fellow who actually we were on a trip for all the first-year students, and we were playing cards, and he was losing some money, and he was writing some IOUs, so I had to get to know him. And we ended up starting a small company together, and we had the very first computer store in Copenhagen where you could walk in and actually buy a computer. And back then it was mostly kit computers that you had to put together yourself, but then we also ended up selling Apple IIs and TRS-80s, you know, later. And I did a lot of just programming on these things, and in the beginning, you know, you sort of program in what's there, like in BASIC, and that gets boring pretty quickly. And then you start writing machine code, you know, because that's when you could really get down to the metal. And then you sort of start experimenting with like writing stuff for the machine, like extensions to the ROM BASIC, or a small operating system, or an on-screen editor. And then eventually, and I wanted to write an Algol compiler, and then my friend was going, no, there's this other thing called Pascal, you should check it out. It sounds really cool. And ended up writing a subset of Pascal with a little on-screen editor and a little runtime package, and it was only 12K of machine code, and it fit into a ROM. So you could yank out the Microsoft ROM BASIC and put in the Pascal, and then when you turned your computer on, you were sitting in a little on-screen editor, and you had Pascal. Now, it was a subset of Pascal, but of course then that grew into a fuller implementation eventually, and then an implementation for CPM80, you know, the 8-bit OS that was on all the micros at the time, and then eventually for PC-DOS. I think around 82, maybe 83, 1983, we ended up meeting up with some other guys in Denmark that had a small company in Denmark. They wanted to get out of the hardware business and into the software business. And they had written a couple of programs. One was called Word Index, which could table of contents and index generator for WordStar, which was this popular text processing system at the time. And they were writing in Pascal. And they were using a very crappy Pascal compiler. And then, you know, we were going, oh, look, we actually have a very good Pascal compiler. You should check it out. And then it's this and that fast. We were telling them, and it had like an on-screen editor. They didn't believe a word of it. And so we said, here, try a copy. And then they came back and go, this is amazing. We should do business together. And then we ended up actually doing a royalty contract, and that's how Borland ended up producing Turbo Pascal. It was our Pascal compiler, you know, rebranded as Turbo Pascal. Obviously, the fact that it took the traditional edit, compile, run, debug cycle and squeezed it from, you know, sometimes it measured in minutes, if not hours, you know, depending on what kind of compiler you were using. Some of them you actually had to swap disks with pass 1 and pass 2 with a compiler, do you know what I mean? And we just brought that down to like seconds, right? And it was instantaneous. And the interactive feel of it made compiled languages feel like they were dynamic or interactive languages, right? And that obviously is just, in retrospect, the right way to do it. So that clearly was one of them, right? I mean, the other was the fact that it would run on any piece of hardware that was contemporary at the time, right? It was only 32K Turbo Pascal, 32K of machine code. So even on an 8-bit machine, there was memory left over for you to write programs. And then I think finally it was the price. At the time, products like that typically sold for $500, and we lowered the price by an order of magnitude down to $49.95, right? And at that point, it's like, well, heck, there's really no point in pirating it. You know, for $49, it's worth it just to get the manuals that explain how it works. Do you know what I mean? So all of those in combination, I think, were quite new and different at the time. Delphi in many ways was really just sort of a successor to Turbo Pascal. I think, I would say, with the Delphi project, I learned personally how to be a better team player. I started out just being a perfectionist, wanting to do everything myself. And so the entire compiler and runtime library was written by me for Turbo Pascal. There were a few other people that worked on the editor and the command driver for the IDE itself. But obviously that doesn't scale, you know, and so eventually you gotta have a team help you out and build the product. I was hired to be the architect of Microsoft's Java development tools. At the time, there was a really big push inside Microsoft to do Java and you know, like even build applications in Java, or maybe even build an entire OS in Java, or, you know, I mean, it was like the time when Java was just taking the world by storm in the early internet days, right? But Microsoft didn't have a Java development tool at all. The closest was their Visual C++ development environment, and that was really not at all the right fit. And so I was brought on to spearhead that. But it very quickly turned into a political battle between Microsoft and Sun. And the product that we had built, Visual J++ 6.0, or it was the 6.0 version, ended up having, you know, a judge in San Jose enjoin it, requiring us to put up warning dialogues about Microsoft proprietary language extensions. So in a sense, that also was the genesis for what came next, which was .NET and C#, because Microsoft as a company realized that it's not going to work for us and for our customers to build our future platform on top of something that we have licensed from some other partner. We knew from our customers that it's too hard to write code at the time. It was too hard to write code in C++, and just not enough programmers could do it. We did have at the time Visual Basic, but that wasn't considered a grown-up, full-blown programming language, and it didn't compile to native code. And so there was a really strong sense that something with the ease of use of Visual Basic, but with the power of C++ was really what programmers wanted. Right? And then so all of those, you take them together, and that was really sort of the genesis for building the .NET framework. And of course, on top of that, then a programming language called C#. Yeah. It turns out that at that time, JavaScript had all sorts of issues. You know, there were no classes, there were no modules, and there was no static type system in JavaScript. So it was very, very hard to write large apps in JavaScript. And also, the tools for JavaScript at the time were really terrible. It felt like you were just coding in Notepad. Do you know what I mean? There was no statement completion and code navigation, or no notion of statically checking your program before you run it. And so teams were actually choosing to write in a different language and cross-compile to JavaScript, just treat JavaScript like an IL, do you know what I mean? And I felt like, wow, well, I mean, if you really want to be best of breed surely that's not how you get to be the best possible JavaScript development environment. What if instead we could fix some of these issues? You know, let's try to figure out what are the issues, what are the problems, and why are the tools crappy, and what can we do to make them better? And that was, in a sense, the genesis for TypeScript. We started out just thinking we were doing open source. We were doing everything the way we used to do it with our internal processes, and then we would sort of lop the source code out in a repository, and then when people logged issues, we'd scrape the issues and put them back into our internal issue tracking system, and that was sort of that. But that's not, well, that's technically open source, right? But it's not open development, where you're actually doing your development in the open as well. And we switched to that after a couple of years, and I think that changed everything, really, because our development process now is, you know, we are so close to our users. I mean, they're literally there every day, and the entire dev team is accessible and on GitHub. You know, that whole workflow allows you to set yourself up to be super fast in addressing issues. So if someone reports a high priority issue, we'll typically have a fix during that day, and the fixed version will be in the nightly build. That is so profoundly different, you know, from how we used to do our work, and it's a much better way to do it. And it's you know, it's better for everybody. It's better for the team too, because it's so rewarding to be that close to your users. Development tools are like the place where programmers invest an enormous amount of time in their programming language and in their developer tool. And because they have such a big investment, they are in the same manner super passionate about these tools. And so when you delight them, there's so much enthusiasm. And ultimately, the rewards you get from seeing people's enthusiasm in using the tools that you've created, it is just very fulfilling. You know, that is, at the end of the day, which after 35 plus years still makes it worthwhile for me to do it, you know, is just that people are so excited about it, and I just love that, you know. Don't be afraid to don't let people tell you that it can't be done. You know, a lot of people will go, oh no, we tried that, it's not possible. You know, well, I mean, that means it might not be possible for you, but maybe someone else can do it. You never know, right? I mean, and we always sort of see in retrospect that, oh, you were thinking about it wrong, right? Or there's this simpler way that you could have gone about it, or so always be curious, you know, and don't take the dogma for given, right?